The most basic way to go about graphing a function is to set up a table of values where you plug in values for x and see what output you get for y, plot those points and start to see the shape that the graph takes. That can be a very long and monotonous process. So what we want to do is start getting into the idea of how we can look at a graph and understand how manipulating the constants in a graph can result in different transformations. If we already have an understanding of some of the basic functions in our library of functions, we know what our starting point looks like, and then we can start to interpret or intuit what happens as we start to adjust different constants for a function f of x. So specifically, if we look at taking a function f of x, where perhaps that function is being multiplied by some value is being added to it, or some value is being subtracted away from that x on the inside. As a quick example, we could consider y equals x squared. If we consider the starting point for each of these different constants, we could write this out in sort of a longer form as y equals 1 times x minus 0, that quantity squared, plus c. So these two expressions that we've written are exactly identical to each other. Let's see, I don't want that to be a plus c. We want that to be a plus 0 at the end. So what we want to start to understand is what happens as this coefficient of 1 changes out front, the value that we're subtracting changes, the value that we're adding at the end changes. How does that impact the graph that we're considering? To do that, we're going to look at a tool that will allow us to manipulate those different constants, a, b, and c, which we have here attached to some sliders. To start off with, we're considering the absolute value function, which hopefully we remember makes that sharp corner at 0 if we're just considering the graph of y equals the absolute value of x. If we start to change things though, specifically what we're looking at is the graph of a times the quantity x minus b plus c. So we want to see what happens as we change those different characteristics. Let's start off by changing this value b. So this value that's being added or subtracted to the x inside those absolute value bars. As b starts to get larger, what we see is that our graph slides to the right. All of the points in unison in their original shape start to slide to the right. As that value for b starts to get smaller, so less than 0, we see that same transformation happening, but now everything's sliding to the left. So we start off with b at 0, and then by changing that to either be a positive or a negative value, we can start to see the graph translate to the right or translate to the left. If we look at this value c that we're adding to the function outside the absolute value bars, we can see that as that value starts to increase, starts to become positive, the entire graph slides up or translates up. As that value starts to become negative, the entire graph starts to translate down. So b and c control slides or translations where the graph just shifts or moves in unison. When we adjust this value for a, that value being multiplied outside the absolute value bars, we're going to see some slightly different behavior. Now what we're going to see is something that we refer to as a vertical stretch. So if you watch those 2 points that aren't at the origin, what's happening is as a gets larger, they're just being stretched straight up in the vertical direction, which has the result of making the steepness of both of those lines increase. So our starting point for that value a was 1. If we come back to a point of 1, where we started, and start looking at what happens as a gets smaller, so between 1 and 0, what we see is those points start getting compressed down towards the x-axis, which makes that absolute value function open wider and wider. So as a is smaller, our absolute value function gets wider because those points are getting compressed down. As a gets larger, those points are being stretched up in the vertical direction, making our graph steeper, or making the opening narrower. Now let's get that back to that starting point. So what we can see from looking at that initial set of changes is that as a gets larger, so meaning a is some value larger than 1, the graph stretched in the vertical direction. And then as a gets smaller, which for right now we're going to think of as a between 0 and 1, the graph compresses vertically. As b gets larger, meaning b takes on some positive value, something larger than 0, we see our graph shift to the right. As b gets smaller, meaning as our value for b becomes negative, we see our graph shift to the left. And then for c, as c gets larger, which again means taking on positive values, then the graph shifts up. And as c gets smaller, meaning c takes on negative values, values less than 0, then we see our graph shift down. So depending on the constant that's being changed, we see those shifts in the horizontal direction, vertical direction, or those compressions in the vertical direction. And we can investigate that with our other graphs as well. So for instance, if we consider the square function or the cube function, now what we're considering is a times that quantity x minus b cubed plus c. We're going to see the same behavior. As we adjust b, the entire graph is going to slide to the right. As b gets smaller, we're going to see the entire graph slide to the left. Taking that back to 0, we can look at our value for c. As that value gets larger, our graph is going to shift vertically. As it gets smaller, it's going to shift vertically in the negative direction, so we're going to see that graph sliding up and down. And what we'll see with a, again, as it gets closer to 0 or between 0 and 1, we're going to see that graph get compressed. So those points that aren't at the origin are going to get squished down or squished into the middle towards the x-axis. As a gets larger and becomes something larger than 1, then we're going to start to see those points get stretched in the vertical direction, so stretched further away from the x-axis. So that same type of behavior is consistent with all of our graphs, including the square root function. Our value for b is going to slide the graph right to left. Our value for c is going to slide the graph up and down. And our value for a is going to cause either a vertical stretch, so those points getting stretched away from the x-axis, or as a gets smaller, it's going to compress those points down towards the x-axis.